Okay, so now we're going to be doing more factoring on the review worksheet, getting ready to go into college algebra. On this one we have 48a to the 8th minus 12a to the 7th b minus 90a to the 6th and b squared. Again, you always want to start by factoring out anything that you can at the start. So 48, 12, and 90 have 6 in common. And while I'm at it, I'm going to factor out an a to the 6th power. That's the smallest power that I could factor out. When I do that, I'll have 8a squared minus 2ab minus 15b squared left. Okay. And now you want to focus on the inside of the parentheses. What can you factor out of that? Well, to draw my little t-square, because I'm going to factor by grouping, 8 times negative 15 is negative 120, and I want factors of that add up to be negative 2. I know that 8 and 15 are factors, but that doesn't help me get to negative 2 by adding. However, 12 and 10 will, if I use the 12 as a negative. They would multiply to be negative 120, and they would add together to be negative 2. So I will rewrite the expression using these two factors, replacing the middle term of the trinomial with these two factors. And then I will draw parentheses, of course, around the first two things and the last two things. And I will factor out what I can from the first set. I can factor out a 4a, and I would have a 2a minus 3b. From the second set, I could factor out a 5b, and I would have a 2a minus 3b left on the inside. And the inside of the parentheses match, which is what you want to happen when you're factoring by grouping. So what we're going to do is we're going to write those once, and we're going to connect our outside pieces, put them in their own set of parentheses, and we'll be done. I don't really need this extra set of outer parentheses now. I could drop that entirely if I wanted to, and be fine. So that is factoring a trinomial. It looks complicated, but if you know how to factor by grouping, you'll be fine. The next one is a difference of squares. In a difference of squares, usually you have a squared minus b squared can be factored into a plus b times a minus b. That's a formula of the difference of squares. And so on this one, if I try to write this as something squared, basically, minus something else squared, I would have to figure out the square root of 49, which is 7. And basically the square root of m to the 8th, that would be an m to the 4th, because properties of exponents say when you distribute this exponent, you're going to be multiplying. So check, make sure if you distribute this, you would get what you had, and you do. The square root of 9n squared is just 3n. And so now this is in difference of squares format. It can be rewritten as 7m to the 4th minus 3n times 7m to the 4th plus 3n. And if you FOIL all this together, those middle terms will cancel, and you'll get what you originally had. So that's difference of squares. Again, it's a handy little formula. But if you understand factoring well enough, then it becomes clear the more you work with it, and you don't really need your formula. 17 is a little icky looking. We're going to use a substitution on it. You don't have to, but that's going to really help make it manageable for you. So what you want to do on that one is let x equal 3r minus 1. If you do that, you have the trinomial 6x squared plus 1x minus 35, which is a lot more manageable. Okay, it's not the greatest, but it's a little bit better. You would want factors of negative 210 multiplying the first times the last. That add up to be the middle coefficient, which is just 1. And you would use 15 and negative 14. Okay, so if you rewrite the expression using these two factors, replacing the middle term with the two factors, and factor by grouping, so this one takes much more room than provided. You wind up getting, and I'm going to skip a step, oh my, it's okay. You can pause and fill in the step because you're smart. You wind up getting 2x plus 5 and then times 3x minus 7. Now what you want to do is recall that x was 3r minus 1. So substitute that back in. 2 times 3r minus 1 plus 5, and then that's times 3 times 3r minus 1 minus 7, which looks kind of gross and everything. But when you work it all out and you distribute and you simplify, you wind up getting 6r plus 3 times 9r minus 10. And so that's actually your answer. And substitution is a really handy trick. You could have used it on this one up here. You could have used it here, and we used it here. So substitution can always help you out when needing to factor things that look a lot more messy than they actually are.